To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
Hello my dear students, welcome to today's lesson. Today also I am going to discuss some more extra questions related to electrochemistry. In the previous chapters also we have been discussing some questions. So I am sure you all would answer these questions by yourself first and then you will compare your answer with my discussion. So I'll move on to the questions. Extra question 31. A special type of electrolytic cell used to produce sodium industrially on large scale is given below. So this is a special type of electrolytic cell. If you look at the cell, I'm sure you will be able to identify the components. So here this is the cell, you all know it is called the down cell. So in the down cell only they extract sodium industrially. In this you can see here through this inlet raw materials are introduced into the cell. Then you can see there is gas A being removed from there and liquid B from there, the outlets. Then here you can see students, the negative, there are two negative electrodes marked, but you all know, you can remember I have explained this to you all, the positive electrode. That is where the oxidation happens. The anode is like a rod in the middle, that is graphite anode. Around that you get a circular perforated steel diaphragm. That is what is shown here. You can see the perforated diaphragm and that is like a circle. So when you cut across the cell, you get the diaphragm on either side of the anode. Then on either side of that also you get the negative electrode, which are the cathodes, but there also you all know it is a circular steel cathode. So the structure is such that it is a special electrolytic cell. In the middle you have graphite anode, then you have the structure Z that you all know is the perforated steel diaphragm and circular steel diaphragm, and around that the negative electrodes, which are the cathodes, you all know it again is the steel cathode and that is also a circular steel cathode. So electrode Y should be the graphite electrode and electrode X will be the steel electrode. So I'm sure you all have identified the components. Then the raw material here, you all know it's fused sodium chloride or molten sodium chloride. And what is taken out as liquid B? You all can remember it is sodium liquid because we are producing sodium metal. And the byproduct is gas A, that is chlorine gas. I am sure you all can remember all that. So we have basically identified all the components labeled in this diagram. Let's look at the questions. The first one, what is the name of the cell? It is the down cell. Down cell. Down cell. Then the second one, identify the electrodes of the cell. What are the electrodes of the cell? Electrode X, like I told you all, this is electrode X, that is circular steel cathode. That is circular steel cathode. Then electrode Y, here you can see the middle one, that is the graphite anode. That is graphite anode. So the cell is down cell, then electrode X is the circular steel cathode and electrode Y is the graphite anode. With that, I'll move on to the next slide where we discuss the rest of the question. Then here also you can see the cell students, the same cell is given there. We have already identified the components. So you will be able to answer the questions. Then here, identify the anode and cathode of the cell. Electrode X, I told you all, is the cathode. That is the steel cathode. So here electrode X, cathode, that is made up of steel. This is just for you all to recall what that element is. And electrode Y is the anode. That is graphite. If you all want, you all can check with the cell also. Their cathode is negative on either side. That is the steel electrode. And here anode is the positive one. That is electrode Y. That is anode, graphite anode. Then, what is the raw material used in the cell? That is fused sodium chloride. Fused sodium chloride. So that is introduced from the top there. Then the fifth one, why is calcium chloride added to the raw material mentioned above? Now I have mentioned this to you all before also. Now the melting point of solid sodium chloride is 840 degrees Celsius. That is a very high temperature, and to melt the sodium chloride you need to provide a high amount of energy. So to decrease that melting point, what they do is they add about 40% of calcium chloride to the raw material, so that the melting point decreases to 600 degrees Celsius. So that is the reason why calcium chloride is added. So reason is to reduce the melting point of sodium chloride solid from 840 degrees Celsius to 600 degrees Celsius. 40% of calcium chloride is added to the raw material. So the reason is to reduce the melting point of sodium chloride solid from 840 degrees Celsius to 600 degrees Celsius. 40% of calcium chloride is added to the raw material. Here this is calcium chloride. So if you all write up to here itself, it's more than enough, but this is for you all to remember. I have written the amount also. So those are the questions to these parts, students. There are some more parts. We will move on to the next slide. So here also you can see the cell given there. Then you can see the questions, what is gas A? So gas A, you all know it's chlorine gas. And what is liquid B? Here you know it is the sodium liquid. And what is structure Z? That is the structure. There you can see structure Z. That is the perforated circular steel diaphragm. So that is what we need to answer here. So what is gas A? Chlorine gas. Chlorine gas. So you all know this is the byproduct of manufacturing or extraction of sodium from fused sodium chloride. And what is liquid B? Sodium liquid. You can write it as sodium liquid or liquid sodium. What is structure Z? Structure Z is the circular perforated steel diaphragm. That is structure Z. Circular perforated steel diaphragm. Is that clear, students? I'll move on to the next slide where we continue with the questions. The ninth one. Again, you can see the diagram there. Question number 9. What is the advantage of having structure Z in the cell? So, what is the advantage of having structure Z in the cell? The circular perforated steel diaphragm prevents the reaction of chlorine gas evolved at the anode with the liquid sodium produced at the cathode. You all know sodium is highly reactive. It can easily react with chlorine gas. If that happens, there is no point of extracting sodium because they will keep on reacting. So here students, you all can see structure Z. We already labeled it as the circular perforated steel diaphragm. What is the reason for having this in the cell? Now you all know sodium liquid is produced near the cathode and chlorine gas is produced near the anode. Now sodium is a highly reactive metal. So that can easily react with chlorine and form sodium chloride. Now we are trying to extract sodium from sodium chloride, and once they are produced, if they start reacting again, there is no point of extracting it. So to prevent the mixing of sodium liquid with chlorine gas so that they won't react with each other is the function of this structure Z, that is the circular perforated steel diaphragm. So it prevents the reaction of sodium liquid with chlorine gas. I'm sure you all can remember that. So if we write that answer, what is the advantage of having structure Z in the cell? It prevents the mixing and reaction of sodium liquid with chlorine gas. Okay, so that is the advantage. Then the next question. Write the balanced half ionic equations for the reactions taking place at the electrodes. Anode. Which is the anode? Here it is the positive electrode, that is the graphite anode, electrode Y. So there chlorine gas is produced, that is due to the oxidation of chloride ions. So what do we write here? Cl minus liquid, you need 2, they form Cl2 gas by losing 2 electrons. That is the oxidation half reaction or the anodic half reaction. Then near the cathode, what happens? Sodium ions get reduced. So here Na plus liquid takes up an electron to form Na liquid. And that is the cathodic half reaction or the reduction half reaction. So we have written the advantage of having the diaphragm, circular perforated steel diaphragm that prevents the mixing and reaction of sodium liquid with chlorine gas. And then the anodic reaction, 2Cl minus liquid form Cl2 gas by losing 2 electrons. And the cathodic half reaction or the reduction half reaction, Na plus liquid taking up an electron forming Na liquid. Is that clear, student? So with that, I will move on to the next slide. So here also we have another question. Now this is the down cell, you can remember that. If we look at the question here, what is the advantage of having graphite as electrode Y? Now you all can remember, students, in this particular cell, that is the down cell, we have the anode as graphite anode, but the cathode is steel cathode. Normally in electrolytic cells, we have seen that we use the same material as the electrode, usually carbon electrodes. But when it comes to electroplating, it's different. But here, we use 2 different electrodes. I have mentioned this to you all when I explained the lesson also. You can remember, students. Now, chlorine is also a reactive gas. So, carbon graphite is an inert electrode. So that means the reactive chlorine gas will not react with carbon graphite. So that is the purpose of using graphite as electrode. Why? Because it is an inert electrode. But at the same time, we use steel as the cathode. Now both sodium liquid and steel both are metals. And sodium is more reactive than iron or steel. But sodium does not react with iron. So because of that, they are able to use steel as the cathode and they have to use graphite as the anode. So that is what you need to remember. What is the advantage of having graphite as electrode? Why? What is the advantage? It is an inert electrode. Therefore, chlorine gas will not react with it. So that is what you need to remember there. Then, if we look at the 12th part, write 2 uses of sodium. What are the uses of sodium here? You all can remember it is used to produce sodium vapor lamps. Lamps used as street lamps with a yellow color light. So that is sodium vapor lamp. Then we use it in laboratory experiments. You can remember reaction of sodium with water. We cut it and look at the freshly cut sodium. So we use it in the lab. And also it is used as a coolant in nuclear reactors. So those are the uses of sodium. We can write any two uses of sodium. I will say used in the laboratory for experiments. Then used as a coolant in nuclear reactors. So used in the laboratory for experiments, used as a coolant in nuclear reactors, or you can say to produce sodium vapor lamps. So those are the uses of sodium. And you all know in this process, gas A, that is chlorine gas, is the byproduct. And we have discussed the uses of chlorine gas as well. So with that, students, I will move on to the next question. Extra question 32. So here you can see a grade 11 student prepared the following setup using a lime and a rod of zinc and a rod of copper connected by wires as shown below. So if you look at the diagram here, so you can see this is lime and into that he has pushed 2 rods. One is copper, the other one is zinc, and he has connected, the student has connected a galvanometer using connecting wires. What does this look like? Now when we say lime, you all know it is acidic. It belongs to the citrus family, so usually there is citric acid. Anyway, lime juice is an acid. So there we have acid, then copper and zinc, those are 2 metals. When you connect them with connecting wires and a galvanometer, what does that look like? It is a simple electrochemical cell. An electrochemical cell where a copper metal and zinc metal are immersed in an acid. Only thing is here the acid is from lime fruit. And why do we use that galvanometer? To observe the direction of the current flow, or for that matter, to observe whether there is a current flow. Deflection in the galvanometer confirms that there is current flowing, and from the direction you will know from where to where the current flows. So that is the purpose of this activity, to demonstrate the function of a simple electrochemical cell. So if we look at the questions, What was the student trying to illustrate? The student was trying to illustrate the functioning of a simple electrochemical cell. So we can say student wanted to illustrate the function of an electrochemical cell. Then the second question, what will be the observation? What will be the observation? You will see a deflection in the galvanometer. Deflection in the galvanometer. That is what is noted as G there. Then, what is the function of copper and zinc? What are they? They function as the electrodes. What is the function of copper and zinc? They function as the electrodes. So, they are the two electrodes. And you all can remember, students, now this is to recall what you have learned before when we take zinc and copper. Now, zinc is more reactive than copper. Why? Because you all can remember copper is below zinc in the activity series. So, that means zinc will act as the anode and it will undergo oxidation. How? Zinc solid loses electrons and forms zinc 2 plus aqueous, losing 2 electrons. Now, if it was a normal cell, you will see the dissolving of zinc, but here it is inside the lime fruit, so you can't see the dissolving of zinc. At the same time, copper will be the cathode. That is where reduction takes place. Here, how will the reduction occur? You all know in acids there are H plus ions. So, the H plus ions will take up electrons and form H2 gas. Now again, if it was a normal simple cell, electrochemical cell in the laboratory, you would have seen the evolving or liberation of gas bubbles near the copper rod. But here, of course, that is pushed into the lime, as well as lime is a small fruit with a lesser amount of acid, and these are small metallic rods, so you might not be able to see the liberation of gas bubbles and dissolving of zinc. That is why I did not specify that as the observations. But you all know these are the changes taking place there. So, zinc acts as the anode and copper acts as the cathode. So, they act as the electrodes there. You all can remember that. So, this is just for a revision of what we have learned before to recall information. So, I have given that as a note. So, with that, I'll move on to the next slide. Again, the questions continue. So, there you can see, students. Again, we have the same setup, the activity. And why did the student use a lime? Why did the student use a lime? To get the acid. Or we can say, because lime contains acid. Or you can say, lime juice is acidic. You can write it any way, it is fine, because lime contains acid or lime juice is acidic. Then the fifth one, in what direction does electrons flow in this setup? Now I will go back to the previous slide. Here you can see, students, Now zinc undergoes oxidation, losing electrons. So because of that, the zinc electrode becomes the negative electrode. Whereas H plus ions take electrons from copper. So copper becomes the positive electrode. So what happens to electrons? Electrons flow from zinc to copper through the external circuit. At the same time, current flows from copper to zinc. You all have to remember that. Electrons flow from negative to positive electrode. Current flows from positive to negative electrode. In what direction does electrons flow in this setup? From zinc to copper. From zinc to copper. Then the sixth one. In what direction does current flow in this setup? From copper to zinc. So they are from copper to zinc. And the seventh one. What is the name given to the above cell if you prepared it in the laboratory with dilute sulfuric acid instead of lime? So there dilute sulfuric acid will be used instead of lime. Still you will have the copper and zinc electrodes. What do we call them? That will be the simple electrochemical cell. So we can call it as the simple electrochemical cell. So this is the simple electrochemical cell. Now there is another term used to call these cell, students. It is known as a simple voltaic cell. That is when you use dilute sulfuric acid as the solution in the cell and zinc and copper electrodes. We call it a simple voltaic cell also. That is for your additional knowledge. But here we can use the term simple electrochemical cell or a simple cell. So I am sure you all have written all these answers. With that, students, I'll move on to the next slide. Now here we have extra question 33. In this you can see there are two cells. Cell A and cell B given to us. And here you can see cell A, what have they shown here? Now cell A, you can see there are two electrodes and here they have said carbon electrode P, carbon electrode Q. So both are carbon electrodes. And here there is a power supply, the battery, power source. So then you know we supply current and make a chemical reaction to take place. So this has to be an electrolytic cell. So here you need to identify. This will be an electrolytic cell. And here the solution is copper sulfate. And you can recall copper sulfate is blue in color. Then if you look at cell B, what can you see there? Do you see a power supply here? No. At the same time, you can see iron electrode and copper electrode, two different metals. And also you see solution 1. So there you all know this should be an electrochemical cell. So this will be an electrochemical cell. Electrochemical cell. So two cells are given to us. Once you look at the cells, you should identify whether it's electrolytic or electrochemical cell. So in an electrolytic cell, we supply current and a chemical change takes place. Whereas in an electrochemical cell, from a chemical reaction, electricity is generated. So chemical energy to electrical energy. I'm sure you all can remember all that. Then if we look at the questions given. First one, identify the process taking place in the above cells. So I have already identified them. Cell A, electrolysis or electrolysis. Electrolysis process. In cell B, electrochemical reactions. We can say reactions or electrochemical process. mainly you have to say cell A is electrolysis and cell B is electrochemical cell. Then the second one, write the energy conversion taking place in cell B. Cell B is an electrochemical cell. Their chemical energy is converted to electric energy. So, chemical energy is converted to electric energy. Then the third one, state the convention used to identify the anode and cathode in cell A. Now you all know, in an electrolytic cell, when we connect the power source, the positive terminal of the battery is connected to one electrode and that electrode becomes the positive electrode. The negative ions get attracted to the positive electrode and get oxidized. So there, the positive terminal becomes the anode. At the same time, the negative terminal of the battery is connected with the other electrode and that electrode becomes the negative electrode and the positive ions get attracted to the negative electrode and they undergo reduction. Because of that, the negative electrode becomes the cathode. So here the question is, state the convention used to identify the anode and cathode in cell A. So anode and cathode based on oxidation and reduction. That never changes. So that is what we need to say there. So there, oxidation occurs at the anode and reduction occurs at the cathode. So those are the answers to these questions based on two cells. Cell A electrolytic cell, cell B electrochemical cell, and those are the changes. Then the energy conversion in cell B, chemical energy to electric energy, and the convention used to identify the anode and cathode, whether it's cell A or cell B, it can be electrolytic cell, electrochemical cell. Always oxidation occurs at the anode, reduction occurs at the cathode. That is what you have to remember. Then I'll move on to the next slide where we continue with the questions. You can see the same diagram there. Then the fourth part, write the half ionic equation for the reaction occurring at the anode of cell A. So reduction occurs at the cathode, oxidation occurs at the anode. Now here, if it is an electrolytic cell, what is the ion that undergoes oxidation? It is the negative ion. Negative ions get attracted to the positive electrode. So here you can see the negative ions in copper sulfate solution, CuSO4, Cu2 plus is the positive ion. Negative ion, there are two negative ions, sulfate ions and OH minus ions. Out of that, it is the OH minus ions that get oxidized at the positive electrode. So here this is the positive electrode, here it is going to be the OH minus ions that get oxidized. So write the half ionic equation for the reaction occurring at the anode of cell A. Anode is carbon electrode P. So there it is going to be 4 OH minus aqueous become 2 H2O liquid plus O2 gas, losing 4 electrons. So that is what happens at the anode. Then, at the same time, write the half ionic equation for the reaction occurring at the cathode of cell A. So there we have Cu2 plus and H plus from water. When there are two positive ions, two cations, what has the higher probability of getting reduced? The metal that is below in the activity series. So when you take H plus and Cu2 plus, copper is below hydrogen in the activity series. So copper will get reduced. So here what should you write? Cu2 plus aqueous, taking up 2 electrons, getting Cu solid. Copper 2 plus ions take up electrons and form copper. Usually copper will deposit on the cathode there. That is carbon electrode Q. Then you can see, write the half ionic equation for the reaction occurring at the anode of cell B. Now if you take cell B we have iron and copper. So you can remember, students, if we take these metals, iron and copper, you all know iron is more reactive than copper. So because of that, iron undergoes oxidation. So copper will act as the cathode because reduction will occur there. So that is how we identify the metals. And another thing you all can remember, students, when we represent an electrochemical cell, usually the more reactive anode is written on the left hand side and the less reactive metal, that is the cathode, is written on the right hand side. From that also you can identify, but still you have to remember the activity series. When you consider the reactivity, iron is more reactive than copper. So because of that, iron undergoes oxidation and reduction occurs at the copper electrode. So that becomes the cathode. We are supposed to write the reactions. So there are, of course, what do you think? Solution Y, it will be an acid solution. Usually it is dilute sulfuric acid. So if we are to write the half ionic equation for the reaction occurring at the anode of cell B, that is iron. So iron, Fe solid, will undergo oxidation, forming Fe2 plus aqueous, losing 2 electrons. That is going to be the reaction at the anode. Then the seventh one. Write the half ionic equation for the reaction occurring at the cathode of cell B. At the cathode, what will happen? There is going to be H plus ions in the solution, because H2SO4 will dissociate to give H plus and SO4 2 minus ions. These H plus ions will take up electrons from copper. So that is what happens there. 2H plus aqueous takes up 2 electrons, forming H2 gas. So that is the reaction occurring at the cathode of cell B. I'm sure you all can remember all these, students. So just to quickly go back and see. Now, if you take the first one, cell A, it is an electrolytic cell. So there is copper sulfate and electrodes are both carbon electrodes. Therefore, near the anode, it is the oxidation. So there in the solution, there are going to be CuSO4 and water. So sulfate ions and OH minus ions are the negative ions. Both of them go towards the positive electrode, but out of the 2 negative ions, it is OH minus ions that get oxidized. So here, if we write the equation for OH minus aqueous becomes 2H2O liquid plus oxygen gas and 4 electrons. Then the reaction at the cathode. Cu2 plus ions and H plus ions are there. Cu2 plus is less reactive, lower in the activity series. Because of that, that gets reduced. Cu2 plus aqueous plus 2 electrons giving copper solid. At the same time, if you take cell B, there is solution Y. I told you all it has to be the electrochemical cell. So it is dilute sulfuric acid. And iron electrode and copper electrode, iron is above copper in the activity series. So that means iron is more reactive. It undergoes oxidation. So therefore, here you can see Iron gets oxidized, Fe solid becomes Fe2 plus, losing electrons. That is the anode of the cell, anodic reaction. At the same time, in the solution, there is going to be H plus ions from dissociation of sulfuric acid. That undergoes reduction. 2H plus aqueous take up electrons forming H2 gas. So those are the reactions here, students. With that, again, I'll move on to the next slide where we continue the questions. The same cells are given to you. Part 8. A part, what change in color occurs in electrolyte solution when cell A operates? Cell A operates, what is the color change you observe? Now copper sulfate is blue in color. And here both are carbon electrodes. So when copper ions deposit, they undergo reduction, deposit on electrode Q, the color of the solution will decrease gradually. So what change in color occurs in electrolyte solution when cell A operates? The blue color decreases gradually. B part, explain the reason for the above. Copper ions from the solution deposit as Cu solid. Because of that, the color decreases. So we can say Cu2 plus ions from the solution undergo reduction. Therefore, the Cu2 plus in solution decreases, leading to the decrease in blue color. So that is what you have to give there. You have to say Cu2 plus ions from the solution undergo reduction. Therefore, the Cu2 plus in solution decreases. Or we can say the amount of Cu2 plus. The amount of Cu2 plus in solution decreases, leading to the decrease in blue color. That is what you have to explain here. Then the ninth one, which electrode dissolves when the above cells operate? Now, both cells, they have commonly asked above cells operate. Will there be a change in the electrodes in cell A? Both are carbon electrodes. Now, you all know carbon electrodes are inert electrodes. They don't undergo any change during the operation of the cell. So, there will be no change there. But in cell B, iron and copper, we already saw that iron undergoes oxidation. So, iron becomes Fe2 plus ions. That means iron will dissolve. Whereas copper will act as the cathode. There you will see the liberation of hydrogen gas. So, which electrode dissolves when the above cells operate? Iron electrode. Iron electrode, I will say in cell B. Iron electrode in cell B. That is what you have to remember. With that, students, again I'll move on to the next slide. The question continues. Part 10, you have the same diagram. Part 10, fill in the following table related to the above cells. So, we have discussed all these. Now, you need to fill up the table. The electrodes, cell A, cell B. In cell A, what is the positive electrode? Now, I told you all, because this is positive, electrode P becomes positive, electrode Q becomes negative. So, positive electrode is electrode P. Electrode P. Negative electrode is electrode Q. Now, here we can write P and Q only. That is also fine. Without writing electrode P, electrode Q, you can just say P and Q. Then what is the anode? What is the cathode? So we have already written that near carbon electrode P, that is the positive electrode, OH minus ions undergo oxidation. So that is the anode. So here electrode P is the anode. So near the negative electrode, Cu2 plus ions take up electrons and deposit as copper. So that is the reduction reaction. So Q is the cathode. So positive electrode P, negative electrode Q, anode is P and cathode is Q. I have written these two in two different ways. You can follow this format or only write the letters. Both are correct. That is why I have used both methods here. Same way, if we try to write for cell B, what are the positive and negative electrodes? Now iron dissolves, leaving the electrons on the iron plate. So iron becomes the negative electrode, whereas hydrogen ions take up electrons from copper. So copper is the positive electrode. Positive electrode, copper, and negative electrode, iron. Here also, if you want, you can use the symbol Cu and Fe. Then anode and cathode. Iron undergoes oxidation. So iron is the anode, iron, and copper is the cathode. So anode is iron, copper is cathode. So this is a question, students, where we have recalled all the conventions, all the changes taking place in both the electrolytic cell and the electrochemical cell. I am sure you were able to recall all that what we studied before. So with that, I will move on to the next question. So extra question 34. We will look at the question first. So here you all can see the diagram shows a setup used by a group of students to observe electrolysis of acidulated water. So here you can see, students, when we look at electrolysis of acidulated water, the electrolytic cell is somewhat different from the other cells. Why? In other cells, what do? We take a beaker, we take the solution into it, electrolyte solution, and then we connect the two electrodes using the connecting wires and the power supply, and when we dip the electrodes into the solution. But here, instead of doing that, you can see we have a plastic cup or a plastic vessel there. We make two holes in the plastic vessel. We insert the carbon rods or carbon or graphite electrodes into that, and then we seal the holes, either using silica or wax or even PVC, so that water will not leak from it. Then we take the acidulated water into this plastic cup, and here you can see the power supply is connected to the two electrodes. So from the power supply, here you can see the positive and negative terminals. Because of that, what is labeled as electrode A will become the positive electrode, electrode B will become the negative electrode. And also you can see there are two test tubes inverted over the two electrodes. When we do the activity, you can remember, students, we fill the two test tubes completely with water and then we invert it over the two electrodes. And when the electrolytic process is taking place, you can remember there is downward displacement of water and gases collect over water. And here the gases are labeled as gas X and gas Y. So you all know in this process both oxygen gas and hydrogen gases are liberated. And you all know the difference in volume also. Usually hydrogen gas is obtained in more volume than oxygen gas because of the final cell equation. You can remember that. So that is the electrolytic cell shown in this diagram. We have identified most of the things. So then, if we try to answer the questions here, you can see the first one, why are carbon electrodes used in the activity? You all know, students, carbon electrodes are inert electrodes. So they do not undergo any changes during electrolysis because they are inert electrodes. So if we say they are inert electrodes, that is more than enough. That is understood that they will not undergo any changes. Then the second one, name the anode and cathode of this setup. So here students, you all have to remember when we have acidulated water. So just to recall what happens in the solution. So as a note, I will explain that to you all. Now there are H plus ions, OH minus ions and sulfate ions from acid. So we have only H plus ions from water and acid. So they move towards the negative electrode and take up electrons and get reduced to H2 gas. So that is the reduction. So the negative electrode where reduction occurs is the cathode. And at the same time, towards the positive electrode, it is both OH minus and sulfate that go there, but only OH minus gets oxidized. So 4 OH minus ions give rise to 2 H2O liquid, O2 gas, losing 4 electrons. Now here also we can put the physical states H plus aqueous and H2 gas. So this is the oxidation reaction. Oxidation, so it is the anode. So the negative electrode is the cathode and the positive electrode is the anode. So there, if we go back to the question, you can see students, this is the positive electrode where oxidation occurs. So that is the anode. So electrode A is the anode. Anode is electrode A. And cathode is electrode B. Anode is electrode A, cathode is electrode B. That is how we write the two electrodes. Then the next question. Identify the gases X and Y. We already identified the gases. You can see here students. Now negative electrode, it is going to be hydrogen gas. And positive electrode, it is going to be oxygen gas. So if we are to identify gas X and Y, gas X is what? The positive electrode. So it is going to be oxygen gas, O2, or you can say oxygen gas. And gas Y is H2 or hydrogen gas. Hydrogen gas. So like I always say students, you don't have to write everything in your answers. This is for you all to know that you can write it either way. You can either say O2 gas or H2 gas or oxygen gas and hydrogen gas. The symbols or the words can be used. So with that students, I'll move on to the next slide where we have another part for this question. So here you can see fourth one. Briefly explain why the volume of gases collected in the test tubes are different. So here volume of gases collected, now we identified this is O2 gas and this is H2 gas. Why is that different? Now I showed you all the reactions in the previous slide. If I go back to the slide, here you can see we wrote the equations. So in this, if you want to balance the equations, if you want to write the cell equation, what do you need to do? Here there are 2 electrons, here there are 4 electrons. So because of that, you need to multiply this by 2. So what will happen? You will get 4H plus aqueous plus 4 electrons plus 4 OH minus aqueous, giving you will get 2 H2 gas plus O2 gas plus 2 H2O liquid and 4 electrons. We can cancel off the electrons. So you will get 4H plus 4OH minus, giving 2 H2 gas and 1 O2 gas. Because of that, the ratio between H2 and O2 is to 2:1. So if you get 1 volume of oxygen, you will get 2 volumes of H2. That is what you need to explain for the next question. So here you can see, students. In this, what we can do is we can write the equation there. So here we can say 4H plus aqueous plus 4OH minus aqueous gives rise to 2 H2 gas plus O2 gas plus 2 H2O liquid. Now this is 2 volume is to 1 volume. So we can say, according to the above equation, the volume ratio between hydrogen and oxygen is 2:1. That is why when 1 volume of oxygen is collected, 2 volume of hydrogen is collected. So that is the reason why we get 2 different volumes. So here you can see the question briefly explain why the volume of gases collected in the test tubes are different. So you can say according to the equation, the volumes are different. The ratio between hydrogen and oxygen is 2:1. So because of that, you get different volumes of gases collected. Is that clear, students? So then I'll move on to the last question of this chapter. Extra question 35. Some methods used to prevent rusting of iron are given below. So in that you can see method 1, applying paint, method 2, galvanizing, method 3, copper plating, and method 4, welding a block of magnesium that is into an iron object. So there you can remember, when we do galvanizing, we coat zinc over iron. Applying paint, paint is applied over iron. In those instances, the contact of water and oxygen with iron is cut off. So because of that, iron does not rust. When we say copper plating, they are also the same thing, copper plated iron object. There is no contact of oxygen and water with iron. So because of that, there is no rusting. But when it comes to welding a block of magnesium, magnesium is more reactive than iron. Because of that, it gives a sacrificial protection or cathodic protection. You can remember that. Magnesium acts as the anode, iron acts as the cathode. So because of that, iron does not rust. So those are different methods of rusting. So the first question, how does method 1 prevent rusting? By preventing the contact of iron with water and air. So here we can say by preventing the contact of iron with oxygen and water vapor in the atmosphere. So that is how method 1 prevents rusting. Second one, what is the metal used to protect iron from rusting in method 2? Galvanizing, it is zinc. You all know the process. They heat zinc to a high temperature so that zinc melts and you get liquid zinc. It will be there in a tub or a container and the iron object is submerged in that liquid zinc metal. There will be a coating of zinc metal over iron. And that process, galvanizing process, is not an electrolytic process. It is not an electrolytic process. You have to remember that. So, what is the metal used? It is zinc. You can either write in words or use the symbol. Is galvanizing an electrolytic process? I just said it. No. It is not an electrolytic process. So, if we write no, that is fine. I will continue the question in the next slide also. So, here the next question, that is part 4. What is the name of protection given in method 4? So, you can remember in the previous one, method 4 is welding a block of magnesium. I told you all it is cathodic protection or sacrificial protection. So, we can write the name cathodic protection or sacrificial protection. So, that is the protection in method 4. Then fifth one. What will happen to iron if the copper plating is scratched in method 3? I have explained this before also, students. You can remember copper is below iron in the activity series. So, if you have copper and iron together, we have done that activity also. Copper will act as the cathode, iron will act as the anode. Therefore, iron will undergo rusting. So, until the coating is there is no contact of water and air with iron. So, therefore, there will be no rusting. But when the coating is scratched, then iron is exposed to both oxygen and water vapor. Therefore, iron will rust. So, here the question is, what will happen to iron if the copper plating is scratched in method 3? Then, iron will act as the anode and undergo rusting, while copper acts as the cathode. So, here there is more chance that iron will undergo rusting even faster than normal because cathode is copper and iron becomes the anode. So, the rate can be accelerated. So, that is something you all have to remember. Then the last question. Will the problem you mentioned above occur in method 2 if the metal coating is scratched? Why? Now, if you can remember, method 2 is galvanizing. There we use zinc. So, what happens there? Now, you all know zinc is above iron in the activity series. So, even if the coating is scratched, zinc will act as the anode, iron will be the cathode. So, it is like a cathodic protection, like this one, cathodic protection. So, because of that, iron will not rust. So, here they have asked, will the problem you mentioned above occur in method 2 if the metal coating is scratched? So, the answer for that is no. Why? Because zinc is more reactive than iron. Zinc will act as the anode and iron will be the cathode. Therefore, iron will not rust. So that is something you have to remember, students. If you use a metal that is above iron in the activity series, they will always act as the anode. For example, magnesium and zinc. Those metals will act as the anode. Therefore, iron becomes a cathode and it will not undergo rusting. So that is the cathodic protection or the sacrificial protection. I am sure you all can understand all those methods well. So with that, students, I have come to the end of this chapter and for that matter, the end of this lesson. So in all these chapters, we discussed the process of electrochemical cell, and then we looked at the electrolytic process, industrial application of electrolysis, and thereafter rusting of iron. And we did a lot of questions related to that. So I'm sure you all have a very good understanding of that lesson, electrochemistry.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.